ඉබුවන් සියලු දෙනාටම අපි අද ලීඩ්ස් මීටින් එක පටන් ගන්න හදන්නේ සහායට. අද අපි කතා කරන්න හදන්නේ අලුත් දෙයක්. ඒ කියන්නේ අලුත් නිෂ්පාදනයක් ගැන ලංකාවේ. මේක මේ ෆර්ටිලයිසර් කම්පැනි එකක්. මේක ලංකාවේ තියෙන ලොකු ප්‍රශ්නයකට විසඳුමක් දෙක කියන එක දැනගන්න පුළුවන් වෙයි. අද අපි මේක ඩිස්කස් කරනවා. ඊට ඉස්සෙල්ලා අපි කතා කරන්න ඕන දෙයක් තියෙනවා. මොකද දැන් අද මේ වෙලාව වෙනකොට earthquake එකක් වෙලා තියෙනවා Turkey and Syria කියන රටවල් වල. 24500ක් මැරලා තියෙනවා 80000ක් injured. ඉතින් මේකට මේ aid workersලා දීලා තියෙනවා රටවල් 100කින් ගන්නට ආධාර ලැබිලා. මේ කටයුත්තට පුළුවන් තරම් උදව් කරගෙන යනවා. ඉතින් මේ වෙලාවේ අපි ඉතින් sadness එකක් තියෙනවා, empathy එකක් තියෙනවා. ඒ වගේම අපි gratitude එකක් වෙන්න ඕනේ උදව් කරන අයට. එන්න අපිට පුළුවන් තරමින් කොහොමද පුළුවන් නම් සපෝට් එකක් කරන්න එකක් හොඳයි කරන්න පුළුවන් නම් ඒ අතරේම අපි බලන්න ඕනේ අපිටත් ඉගෙන ගන්න දේවල් තියෙනවා. දැන් මේ වගේ earthquake එක මේ කාන්සිං අපිට නෙමෙයි රටේ මේ earthquake වෙනවා කියලා දැනගෙන හිටපු තැනක්. එතකොට මේවා අඩු කරන්න මිටිගේෂන් එකකට ක්‍රමයක් තිබිලා තියෙනවා. ඒකට ස්ටෑන්ඩඩ්ස් වගේක් හදලා තිබිලා තියෙනවා. ඔයාලා මෙතන දැන් පින්තූරේ බැලුවා නම් මෙතන පේනවා මේ සමහර flats එකක්වත් වැටිලා නැහැ. සමහර ඒවා වැටිලා තියෙනවා. එතකොට why some flats did not collapse කියන question එක ගෙනවා. එතකොට මෙතන ඇතුලේ තියෙන මේ constructions වල deviations තිබුණා කියන ඉතින් මේකෙන් පේනවා මේ corruption activities වලින් රටේම මිනිස්සු වලට තියෙන හානිය අඩු කරගන්න එකත් බැරි තත්යකට ඇවිල්ලා තියෙනවා. ඉතින් මේවායින් අපිට ඉගෙන ගන්න දේවලුත් තියෙනවා. ඒ අතරෙම ඉතින් අපි මෙහෙම දෙයක් වුණාම සාමාන්‍ය මිනිස්සුන් තමයි වැඩිපුරම හම්බරේ. ඉතින් ඒගොල්ලන්ට උදව් කරන්නත් අපි ඕනේ. අද අපි කතා කරන්න යන්නේ biofilm fertilizer ගැන. ඒක මේ promising approach to fertilizer crisis. දැන් මේක අපි මේ report එක බලුවොත් කරගෙන යන්නේ මේක අපි අපේ leads mission එකට මතකත් වෙන්නේ මොකද අපි ලංකාවේ තියෙන ප්‍රශ්නේ විසඳගන්න items තුනක් අපි identify කරගෙන ඒ වෙනුවෙන් තමයි වැඩ කරගන්නේ. එකක් තමයි reduce wastage. ඒක අපි ලොකු දෙයක් ඒක කතා කරගෙන යන්න ඕනේ. එකක් තමයි අපේ increase productivity. ඒක වැඩි කරගන්න ඕනේ. ඒක නැතුව අපිට රට හදා ගන්න බෑ. තුන්වෙනි දේ තමයි මේක. research and innovation. දැන් මේකට අදාළ දෙයක් තමයි අපි අද කතා කරන්න බලාපොරොත්තු වෙන්නේ. මේක තමයි Ceylon Journal of Science එකේ තිබුණු paper එකක්. Biofilm biofertilizer can reinstate network interactions for improved rice production. ඉතින් මේක ලියලා තියෙන කටුවරු මෙතන දන්වලා තියෙනවා. එතකොට ඒකේ දැන් මේ report එක දීලා තියෙන්නේ around 208,000 acres of paddy fields throughout the island have been successfully cultivated using biofilm fertilizers in the 2022-2023 Maha season under the eco-friendly fertilizer project. මේ report එක කරන්නේ Professor Ganesh University senior research scientist කෙනෙක් National Institute of Fundamental Studies. එතකොට මේ biofilm fertilizer කියන්නේ is a type of biofertilizer aimed at reviving deteriorating soil conditions in Sri Lankan plantations due to excessive application of chemical fertilizer and agrochemicals. ඉතින් මේකේ බලාගෙන යනකොට මේ අර organic cultivation කියන පැත්තට හැරෙන්න පුළුවන් වගේ එකක් කියලා අපිට හිතෙනවා. හැබැයි ඉතින් මේ ගැන ඉතින් අපි අහන්න ඕන මේ රිසර්ච් කරපු අයගෙන් තමයි. ඉතින් ඒක නිසා මම ඉතාලම සතුටුයි ප්‍රොෆෙසර් ගාමිණී සෙනවිරත්න මේ නිෂ්පාදනයට මුල්මක් කියපු සහ ප්‍රොෆෙසර් ගුලසූරිය අද සහභාගී වෙලා ඉන්නවා මේ ගැන කතා කරන්න. ඉතින් ප්‍රොෆෙසර් ගාමිණී සෙනවිරත්න කියන්නේ senior research professor National Institute of Fundamental Studies in Canada. He's a PhD, PhD from University of Peru. Postdoctoral fellowships, Belgium universities, Australia, Sydney University. He's a fellow of the National Academy of Sciences of Sri Lanka. And he's a former editor of the Science Journal, Agriculture, Ecosystems and Environment, and Ceylon Journal of Science. He introduced this microbial biofilm concept to biofertilizer. Professor Kulasuriya, BSc, PhD, BSc, Emeritus Professor University of Pennsylvania, 40 years service on academic staff, head of Department of Botany, Dean Faculty of Science. 39 years of service at the National Institute of Fundamental Science as a visiting research professor. Soil microbiology, biological nitrogen fixation, and soil fertility. ඒ තමයි area වැඩිම දන්නේ. ඒ අතරෙම cyanobacteria සහ algotoxins ගැන ස්පෙෂලිස්ට් කරලා තියෙනවා. ඉතින් අද මම ඉතාලම සතුටුයි මේ අය ඉන්ට්‍රොඩියුස් කරන්න. ඒ වගේම ප්‍රොෆෙසර් ගාමිණී සහ ප්‍රොෆෙසර් කොච්චරි අද මෙතන ඉන්නවා. ඔයගොල්ලන්ගේ මේක පටන් ගන්න පුළුවන්.
Good evening to all the participants. First of all, I like to convey our thanks as Kamini and I both for giving us this opportunity to present our innovation on biofilm biofertilizers. And the title assigned to us by the organizers is Biofilm Biofertilizers, a Sri Lankan Innovation for Sri Lankan Benefit, how we got there from bench to the field. Now, within this broad thing, I would like to first make a short presentation on the background of the development of biofilm biofertilizers. Next slide, Kamini. I would like to take a little bit of your time, the origin and the role of microorganisms on Earth. Microorganisms are believed to have been originated from abiotic environment some 3.8 billion years ago, long time ago. And they were the sole inhabitants of Earth for nearly 2 billion years. For 2 billion years, a long time, there were only microorganisms in the entire Earth. And during that time, they themselves evolved to different groups like the eubacteria, the archaea, the actinobacteria, cyanobacteria, fungi, and so on and so forth. And then they occupied all the possible niches on the Earth's surface, including, of course, marine, freshwater, terrestrial, but even the extreme habitats like hot wells or extremely salt marshes and salt crystals even, and glaciers. So any habitat of the Earth that you can think of had been occupied by microorganisms. Now just imagine Earth teeming with microorganisms everywhere, and other organisms are now evolving, eventually, of course, up to higher plants and animals. So whatever organism that evolved during that period had to be invariably associated with microorganisms because you have come out of a microbial pool. So that is the reality, that is nature. And such associations, of course, extended from symbiosis, very strict, intimate associations, symbiosis, commensalisms, parasitisms, and endophytic and ectophytic loose associations. So we have all these diverse types of associations between microorganisms and all other living organisms. For that matter, human beings carry a population of microorganisms which is numerically higher than all the cells that the human being tissues contain. So such a load of microorganisms we are containing, and they are essential for our well-being. In fact, that is what most people now take as probiotics and various preparations to keep healthy. At the same time, one has to realize that there are microorganisms who are responsible for parasitism, pathology, and illnesses. So both beneficial and detrimental microorganisms are associated. Thus, fortunately, out of these, majority of the microorganisms are beneficial or neutral. Only a few are pathogenic. Next slide. Now, most microbial associations have been found to be invaluable for the healthy growth of host organisms, plants or animals. As we know that symbiotic associations with nitrogen fixing root nodules of legumes and mycorrhizal fungi are utilized in crop production. And how do we do that? We isolate the microorganisms responsible, select the best one out of that, and then re-inoculate to a targeted crop. So we have been customarily or traditionally selected and used inoculants with single microbial preparations. Unimicrobial inoculants we have been using over so many years, and that had been going on, that had been beneficial and going on. But on the other hand, as we go deeper into this, we realize that, of course, there are pathogens and parasites against which we have to take precautionary measures. Thank you. Next slide, Gamini. Next slide, please. Yeah. Now, if you go into a deeper understanding of these host microbial relationships, when we go into more and more closer observations, we find that in nature, microbial associations have always been multi-microbial. No plant or animal is associated only with a single or even with a single group of microorganisms. They are always associated with several different groups. For instance, a plant, when you take out a plant, the root system has bacteria, fungi, actinobacteria, cyanobacteria, the entire, and now we have got used to the term called microbiomes. Now, we are used to the root nodules of legumes, and we presumed in the last century or so that there were only rhizobia in the root nodules. But closer look at, especially with electron microscopy and also with molecular techniques, we now find that even inside the root nodule, in addition to the rhizobia, there are several other bacteria and actinobacteria, even sometimes some fungi. Same with another well-known symbiosis called water fern. Solla has a dorsal lobe which has cyanobacteria called anabina. But there again, when you look into that association, you see, in addition to the anabina, there are other bacteria and even actinobacteria associated with that. So now we have to accept the concept of multimicrobial bacteria, archaea, fungi, and cyanobacteria associations in the form of microbiomes is the norm in nature. Although we have not done it artificially, we are inflating single inoculants. Now, this revelation or these observations made Gamini and I to look at multimicrobial interactions. And we have 16 years back, we published that with our research assistant who has now settled down in USA, Pandara, Seneviratna, and Kulosure 2006, Interactions Among Endophytic Bacteria and Fungi, Effects and Potentials. So this, I would say, was the beginning of thinking that eventually led to the development of biofilm biofertilizers, which is called BFBF, by Gamini. Next slide, final slide, I think. Yeah, before I hand over the floor to Gamini, I would like to introduce our definition of a biofertilizer, which is different from all the other fertilizers. A biofertilizer is an entity that enables a close association with a targeted host once applied. And this association continues and remains alive. Now, that's a very important thing to remember. The inoculant that we add continues to remain alive. It doesn't die. And it functions closely associated with the targeted plant or animal. It will continue to function until the host dies. As long as the host lives, the associated inoculant microorganisms also lives. And unlike all the other types of fertilizers, it is not a dead substrate. which provides nutrients to the host from its biomass. Now, all the other fertilizers, whether they are mineral, synthetic like urea, muriate of potash, or superphosphates, all those things provide from their substrate, from their body. Similarly, what you call animal dung or compost or leaf litter or green manure, all of them provide nutrients after death and decomposition from their biomass, not biofertilizers. Biofertilizers associate themselves closely with the targeted host and provides nutrients from external substrates, from substrates that are outside. For example, if take simple example of nitrogen fixation, you add rhizobia or you add any other nitrogen fixing organisms like cyanobacteria or free living eubacteria, they will associate it with the targeted crop and absorb nitrogen from where? From the atmosphere. 78% of the atmosphere is nitrogen gas. They absorb that nitrogen and transfer it to the targeted host. So that is a difference. And that makes us see that you can add very small inoculants, and that is what we do by these biofertilizers, whether they are biofilm or other biofertilizers. You add very small inoculants, a few grams or something. Whereas if you add even minerals, synthetic fertilizers are urea and muriate of potash and so on, you have to add kilograms per hectare. In the case of compost and leaf green manure, you have to add tons, depending on the NPK content that your substrate has. But not in the case of biofertilizers. You add a few grams, then they multiply together with the growth of the host and continue to provide nutrients from external substrates. So with that definition of the biofertilizer as we see it, I would like to hand over the floor now to Gamini.
Thank you, sir. Thank you, Principal Surya, for that detailed description of the background of biofilm. What I would like to do is to continue that point onwards. And especially what I am going to show you is the extension of biofilm biofertilizer to the field. We did it. So this is the basic biofilm, type of biofilm we are using to produce biofilm biofertilizer. It is called fungal bacterial biofilm. So what happens is, this is a fungal filament to which bacterial cells are attached. This is what is called fungal bacterial biofilm. These are the ingredients that are used to produce biofilm biofilm. Here, what happens is, fungal filaments and bacteria, they are closely associated, so surface attached. Then generally we use nitrogen fixing bacteria in these biofilms. Then what happens is, as Professor Kulasuri also explained, nitrogen fixing bacteria fixes atmospheric nitrogen and converted to ammonium and so on, and then amino acids and so on. So that nitrogenous compounds are transferred by the bacterium to the fungus. Thereby, nitrogen nutrition is supplied by the bacterium to the fungus. So in return, the fungus supplies food or organic compounds, carbon sources to the bacterium. Thereby, they establish a close association or symbiosis. And in addition, they produce a wider range of biochemicals which are environmentally important for various ecosystem functions. So they are also secreted by this biofilm as a whole. So this is what is really happening when a biofilm is produced. So they show higher metabolic efficiency to produce diverse biochemicals that reinstate microbial diversity and functioning of degraded ecosystems for sustainability. So this is the principle behind this biofilm. So when they apply these biofilms, they secrete a wider range of biochemicals. In degraded environments, those biochemicals sort of degraded, dissociated, and so on due to human impact, tillage, agrochemical, chemical fertilizer usage, and various things. So when biofilm is applied, that supplies a wide range of biochemicals which are important in ecosystem functioning. So that is the principle. So biofilm biofertilizer in agriculture in Sri Lanka. So we have used biofilm biofertilizers in agriculture and plantations, mainly agriculture. And we have shown that these biofilm biofertilizers can cut down chemical fertilizer use by 50%. When I say chemical fertilizer use, it's the farmers' rate of chemical fertilizers, because most of the farmers use their own rates, and they don't use chemical fertilizer rates recommended by the department, because when the soil is gradually depleting, they increase their rate of application. That's what has happened so far. And some agrochemicals also we can reduce by using these biofilm biofertilizers, and also standard organic, good quality organic fertilizers also can be cut down by 50% at the same time. And while increasing the crop yield up to 20 to 30% on average. So there's a wider range. So on average, we have 20 to 30%. This has extensively been shown in over 100 field trials so far, and we have conducted those trials in over 10 districts for paddy in particular, because we have been asked by the government to produce biofilm biofertilizer for paddy and it to be expanded island-wide and so on. So we have more concentrating on paddy, and in addition, we do some other crops I'll show you later. And also, when biofilm biofertilizer is applied with good quality organic fertilizers, as I said, it makes the paddy cultivation 100% organic to have a healthy rate of rise. So instead of chemical fertilizer 50%, we can use good quality organic fertilizer, about 50% of the recommended rate. So with that, we can use biofilm biofertilizer to have a 100% organic solution that contains only organic fertilizer and biofertilizer, no chemical fertilizer. So that can establish a 100% organic paddy cultivation when we use organic fertilizer. So, yeah. So as even in the introduction, as was mentioned, at present, the BFBF has been recommended by the Department of Agriculture for paddy cultivation due to success. Due to its success in the under field conditions, and also it has been expanded over 280,000 acres of paddy cultivation in the country, and also BFBF has been approved by the Cabinet of Ministers to promote in paddy cultivation island-wide. So due to the successful application, it has also been approved by the Cabinet. So rather than showing my own results, I would like to show this particular result, which was done by the Department of Agriculture independently. This is a paddy grain yield of a field trial conducted by the Department of Agriculture independently during Jala 2021 at Rice Research Station, Parantani, Jaffna, for testing the effectiveness of biofilm biofertilizer on paddy crop performance. Now here, as I mentioned earlier, now when Department of Agriculture conducts field trials, they use their own recommendation. So if you just compare their recommendation with farmers' practice, it's like this. Department of Agriculture recommendation NPK rate of 70% is equivalent to 50% of farmers' NPK rate. That's the norm there. So now this is the result, and I have to mention here that even during this, when they were conducting these trials, we were not even allowed to visit the trials. And what we did was we just supplied the biofilm biofertilizer product, and and the description how it's applied and so on, the protocol. That's all. So they did it independently. So this is the final result. There were several treatments. No fertilizer treatment is this much, paddy granule tons per hectare. Then 100% chemical fertilizer department rate, this much. Then 70% of chemical fertilizer of the department, which is equal to 50% of farmers' practice, this much. So these two treatments are the most important. The next one is 70% again plus biofilm biofertilizer. We use only a small amount of biofilm biofertilizer, like 2.5 liters per hectare, and you get this much. In addition, they had 100% chemical fertilizer with compost. This is the rate of compost application of the Department of Agriculture, 10 tons per hectare. That's a huge amount. So it's this much. So if you compare the third treatment and fourth treatment, 70% chemical fertilizer. The other one is 70% of chemical fertilizer, biofilm biofertilizer. There's a significant increase in the. So this clearly showed that there's a significant, or the biofilm biofertilizer effect is significant, and it gives a real effect onto the green yield. And one might ask the question, why don't you apply biofilm biofertilizer alone? But we don't recommend to use biofilm biofertilizer alone, because when biofilm biofertilizers are applied to the soil, what happens is, as I explained you, that leads to increase the biodiversity and abundance, microbial biomass. So to grow that microbial biomass, a fraction of plant available soil nutrients are absorbed by the microbial biomass. Therefore, plant growth is hampered. Therefore, we don't recommend biofilm biofertilizer alone application. Always use biofilm biofertilizer together with the organic or chemical fertilizer source. Right. I explained you that 20 to 30% yield increase is there with 50% chemical fertilizer reduction. How come? How that has happened? So this is the simple explanation for that. So to explain that, we have to use paddy field mycorrhizal network. So this is the biofilm biofertilizer practice. So as I explained you, what happens is, when biofilm biofertilizers are applied, microbial biodiversity and abundance are increased. So which means even the mycorrhizal network in the soil profile is also increased. Here, what really happens is, now when mycorrhizal network in the soil, especially the deeper layers of the soil profile is enhanced by using biofilm biofertilizers, and this mycorrhizal network is naturally, they connect with the root system, and what happens is, most of the nutrients that are sort of stored below the hard pan in the deeper layers are transported by the mycorrhizal network, and it is supplied to the root system of the rice plant, which is in the plough zone. This is the hard pan, this is the plough zone, this is the deeper soil layer. In the deeper soil layer, there's a huge amount of nutrients, NPK and other minerals are stored, which cannot be taken up by the plants, by the plant roots. But if you increase the microbial diversity, that leads to increase the mycorrhizal network in the soil profile of rice paddy. And our gross calculation shows that 200 to 600 kilogram NPK or per hectare, depending on the soil fertility status of different soils, are transported from the deeper layer to the root zone. That is how we can increase the crop yield while reducing the chemical fertilizer use. So this is the secret behind that. So in chemical fertilizer practice, since we are using a lot of chemical fertilizers, that leads to deplete microbial biomass and network and everything. So therefore, and also it has also very well been shown that in 100% chemical fertilizer practice, most of the nutrients, especially nitrogen, is lost. About 70% is lost, and only 30% is remaining. So therefore, that also leads to a low nitrogen status of the field, and that eventually leads to low yields compared to more, microbial situation. So these are the two rice plants. This is 100% chemically fertilized rice plant. This is the small root system it has. This is the more yellowish. This is biofilm biofertilizer practice. Larger root systems. Rice plant with more greenish color, with lot of tillers compared to this. So this is the difference we can see when we use biofilm biofertilizer in comparison to the chemical fertilizer alone application. So this is the same story, but you can clearly see the difference in color when you look at the rice paddy. This is the chemical fertilizer alone. This is chemical fertilizer with biofilm, this biofilm practice. You can clearly see that this more yellowish, this more greenish. Yeah, as I explained to you, this has now been used in 280,000 acres of paddy cultivation, and also we are now expanding this to other crops gradually. These are the other crops being applied biofilm biofertilizers. This is in Norelia, carrot, wheat. This are in down south, capsicum and tomato. This is the carrot harvest. You can clearly see the size of the tube when we use 100% chemical fertilizer, this much, and biofilm biofertilizer is used this much. This cabbage, the seed potato farm in Italia, they also use biofilms. And this is lease harvest. This tea cultivations, which are using biofilm biofertilizers. Again, vegetable cultivations. Now, this is the other important point that we have to stress. When biofilm biofertilizers are used, that leads to increase the microbial diversity and abundance, and eventually microbial biomass. When microbial biomass is increased, a lot of organic matter is stored in the soil profile. Therefore, soil carbon sequestration or carbon storage in the soil is increased. This is 50% chemical fertilizer with biofilm biofertilizer. This is 100% chemical fertilizer only. So thereby we can contribute this practice. This practice can contribute to mitigate issues like global warming, climate change, and things like that. And eventually, we can use this practice to get carbon, to do carbon trading, which surely earn foreign exchange at the end. Right, this is our commercial partner, Lanka Biofertilizers Private Limited, who is producing biofilm biofertilizers. They have established the largest and most technologically advanced biofertilizer manufacturing facility in Sri Lanka. They have two factories. They are located in Hokandara and Horana. The total floor area of the factory is 60,000 square feet. Production capacity is 1 million liters per annum, and they have up to 10,000 liter fermenters. These are 10,000 liter fermenters. And total investment for this project by our commercial partner Lanka Biofertilizers is over 750 million rupees, which is equal to $2 million US. So they use pharmaceutical grade clean rooms to filling and so on, which are European standards. So these are the products they produce. Biofilm OP for oil palm, biofilm R for rice, biofilm T for tea, and biofilm veg for vegetables. In addition, they have biofilm M for maize, and also they have Dr. Compost as a compost accelerator. And all these biofilm biofertilizers have been certified to be 100% natural and organic by Control Union, that is European Union certificate. So at present, research on biofilm biofertilizers have been conducted in Canada, India, Indonesia, Brazil, Ukraine, Mexico, and Iraq. And they have shown that, their initial studies have been reported in literature, and they say that the results are promising. They are sort of continuing their studies. In addition, USA, Australia, and China have shown their interest to introduce biofilm biofertilizers to their countries. So in conclusion, the engineered microbial biofilms can contribute immensely to solve ecosystem and environmental issues for a healthy life, as well as a livable world in the future. So you asked to present some difficulties we face during the transfer of this technology to the field application. So I got down a few points, especially the first two are technical difficulties. The original liquid formulation, which was sprayed to the crop, had to be concentrated to reduce the rate or volume of application, because when we talked with our commercial partner, they said that the volumes are too large. Then they asked us to reduce the volume or concentrate the product. So that took about 1 year to develop a more concentrated product. And then again, with that concentrated product, we went to the commercial partner and we started discussions. Then they accepted our formulation. Also, when we were applying this to the field with farmers, farmers requested the product in solid base, but not in liquid form, because if we are going to spray this product, it involves spraying cost. They have to pay to the spray and so on. So they asked us to give them a solid base. So what we did was we develop a method to soak the liquid biofilm biofertilizer into a small volume of dry sand and mix it with the granular fertilizer for broadcasting. Also, we can mix this sand soaked biofilm biofertilizer even with granular organic fertilizer. There are granular organic fertilizer formulations. We can mix it, and as usual, we can broadcast onto the field. Thereby, spraying cost is cut off. And also, there were many criticisms by various parties. That's very natural and usual. That also has to be mentioned here when we are developing from the start to the present point. And that's all. That's all that I have to mention. Thank you.
I think congratulations, first of all. It's been brilliant to understand that such a work was done. And that is what we need in Sri Lanka. We need more and more of this kind of work. And obviously there'll be difficulties and criticisms and so on. But that is science. Science is always two sides. You base your thing on the evidence you get. I'm quite happy that you talked about eco-balancing in farming, which is a very good thing to do. And I was wondering, with repeated use, for example, you reduce the chemical fertilizer by 50%, but with repeated use, do you still see the same yield, or does it improve, or does it deteriorate?
Yeah, that's a good question. We have a very large database. We have done a lot of work. In fact, starting from paddy trials, we started in 2015, and gradually we expanded, and large scale trials were started in 2018. So we have done more than 8 seasons so far. So what we have seen is in farmers field, as you go on applying biofilm biofertilizers, there's an increase in trend of yields, and at the same time, increase in trend of soil organic matter and soil fertility status. So now we have sort of started to see whether we can reduce the amount of chemical fertilizer that is being applied with biofilm to make a more eco-friendly practice of biofilm biofertilizer.
Yeah, okay. That's what I thought based on what you presented. I'm not an expert on the subject at all. But another question is that, is there a cost reduction for the farmer now when you use 50% of this and the biofilm? Is there a cost reduction for the farmer?
Yeah, definitely, because our commercial partner, they are very good in commercializing products. They are Lanka Biofertilizers is in fact a subsidiary of Nature's Beauty Creation or Nature's Secret group of companies. So they know how to do this. So they have sort of fixed the total investment for, the total expenditure for biofilm biofertilizer practice below the total 100% chemical fertilizer practice. So
All right,
always they have fixed.
You have a question from Stanley Veeraratna. If you stop sharing the slides, you will be able to see who is asking the question.
Yeah, sure.
Stanley, you can go. Stanley.
Yes, thank you for the interesting presentation by my friend Surya and Dhamini Senivaratna. I just want to get a few points clarified. One is that, as you all know, when you cultivate paddy, say 1 acre, 1 hectare will give about, say, we will say 4,000 kilos. Now that will require about 60 to 70 kilos of nitrogen.
Yeah.
Now that can be obtained maybe in the first instance from biofertilizers like Anabina and so on. But what about the following? Now, this is what you will also ask. That is one thing which I want to clarify. The second point is that now 60 kilos of nitrogen will have to be provided by these 2 liters of the biofilm biofertilizer. What about the potassium and phosphorus? Now already we are having symptoms of maybe phosphorus. In some areas where they have been using no fertilizers or organic fertilizers, the plants are showing yellowing and also tillering is affected. Now, by applying this biofertilizer, how can you provide phosphorus and potassium? Nitrogen, of course, will be fixed by the organisms which you are going to apply. But what about the phosphorus and potassium? Because as you know, they are also necessary for the cultivation, production of crops. And Pule, my friend Pule, we were together at the Peradenia long time ago. Can Pule or Gamini Sengoran explain this?
Yeah, can I? Yeah, first I'll explain a bit on that. So always when we use biofilm biofertilizer, we use it with 50% of chemical fertilizers. That is 50% of urea, phosphate, and potash. So we don't stop applying chemical fertilizer when we use biofilm biofertilizer. And at the same time, if you use organic practice, they also we use good quality compost, like at least those compost has 3 to 5% of nitrogen and also certain amounts of phosphorus and potassium. So thereby we increase that. And the other point is, as I showed you, there's a considerable amount of nutrients deposited below the plow zone, that is below the rooting depth. So that nutrient pool cannot be utilized by the rice plants because rice plant cannot penetrate much through the hard bed. But when we increase the microbial action by using biofilm biofertilizer, it leads to develop a better mycorrhizal network which penetrates through the hard pan into the below soil layers, deeper soil layers. So those mycorrhizal action can sort of extract nutrients that are deposited beneath the hard pan and can be transferred to the routine zone, thereby while we are reducing the amount of nitrogen, phosphorus, potassium, we can at the same time increase because uh, in addition to NPK, there are a lot of nutrients like magnesium and so on, which are very essential for plant growth, which are not applied in conventional agriculture. Those nutrients, additional nutrients are also extracted from below layers to the upper layers, thereby because magnesium is very much important for the production of chlorophyll. Nitrogen and magnesium are the two basic ingredients for. That's why we see the greenish color and so on. So that is the answer. I think that replied to your question.
Thank you, Gamini, but there are two more points which I would like to clarify. One is that some of these organisms, if you apply it to acidic soils, most of our soils in the which zone are acidic. I don't know whether they will function effectively as what you observed in north. The second point is that
biofilm now naturally when a biofilm is developed, that biofilm it's a microbial community, fungi and bacteria. There are various types of biofilm. In this case, it's fungal bacteria. Once the biofilm is developed, they secrete a substance called exopolysaccharide, extracellular polymeric substances. So that helps to protect the biofilm structure. Therefore, when we apply those things, they sort of show a very good sort of resistance to the environmental stress factors like alkalinity, acidity, and so on. So thereby the biofilm functioning is sort of secured compared to the other monoculture microbial formulations in biofertilizers.
have you conducted any studies on this pH values when you apply? You said
Yeah. We have done, and we have published.
Let me finish. Now, if you apply this biofilm, you say that the pH is affected. Have you done any studies on that? Because as you know, in the north,
The paper that was shown by Chula, it also contains the basic pH values with chemical fertilizer and biofilm. I don't have the paper right now, but all the publications we have shown the effect on pH.
Now, most of the soil studies conducted in Sri Lanka indicate that the lower layers have less organic matter than the upper layers.
Yeah.
In fact, the A1 horizon has more organic matter than the B or the C horizon.
Yeah.
So you said that in the B horizon or the lower layers, there is more organic matter. I don't know whether such a statement is correct.
No. In conventional studies that have been conducted in Sri Lanka, they have not used any biofertilizer. They have only done, only research work have been done using biofertilizer. But when you use an effective biofertilizer, as I explained you can increase the mycorrhizal effect in the deeper layers, which has not been sort of researched and shown so far in Sri Lanka. Almost all studies have been done with 100% chemical fertilizers. That's the issue here.
But how can the organic matter level be increased by microbial?
That is very important. Now, in literature, it has been clearly shown that in a cereal like rice, per year, per hectare, they secrete 2 to 5 tons of carbon as root exudates. Right? As photosynthesis is transferred to the root and it is released to the soil. But in 100% chemical fertilizer practice, you sort of deplete most of the microbial biomass around. So there's a small biomass to utilize that carbon, but in a practice like biofilm biofertilizer, which leads to increase the microbial diversity and abundance, those microbes utilize those carbon, 2 to 5 tons carbon. When I say carbon, this is elemental carbon, not the organic matter. If you translate it to organic matter, it's like 8 tons organic matter per hectare per year. That's a huge amount. So that amount can be utilized when we have a biofertilizer like biofertilizer, and that leads to grow more microbial biomass in the soil, and thereby you can increase the amount of organic matter in there. So that
I
is
don't have anything against the application of biofertilizers, but what I think is it's better if we use that and at the same time apply organic matter, maybe like
that we have both
that is a bit
chemical fertilizer and organic fertilizer. Both you can use biofertilizer.
That's a better system to be used.
Yeah.
Thank you.
Okay, thank you.
Very good. Any other questions? Any other questions? Lakshman, yes, Lakshman.
Thank you, Chula. Thank you, Professor Kule and Gamini, for excellent presentation. I am a layman to this field of agriculture, but I have some very basic questions. Now, Professor Kule mentioned earlier, it's not a traditional fertilizer. So what is it? Is it a soil enhancer like thing? And then what are the long-term consequences of using such fertilizer?
Yes, in fact, it is different from all the conventional fertilizers as I showed you, because all the other fertilizers, whether they are synthetic, organic, fresh green material, they are all dead substrates. And their nutrients are supplied from their own biomasses, their own masses, whether they are synthetic chemicals or otherwise. But in the case of biofilm, biofertilizer, or any other biofertilizer, which are live organisms, they don't provide the nutrients from their biomass. They derive nutrients from external surfaces, whether it's soil or air or any other substrate, and then provide it to the plant. And also, in the case of biofilm biofertilizers particularly, we have seen that they not only enhances root growth, as clearly shown by Gamini, how the mycorrhizal component of the fungal component of the biofilm extends the root system, they also activates root absorption by producing a lot of hormones, because a conglomerate of bacteria and fungi which together enhances root growth and root activity, absorption. So in both ways they enhance. But for instance, the soil or the substrate should have some fertility. If you add biofilm biofertilizer to a sandy soil or a desert soil, probably plants will die. So you need certain amount of fertility, inherent fertility in the substrate, in the soil in this case, and that absorption as well as availability is increased. That is the action which is different from all other fertilizers that you can think of. Thank you.
Yeah, thank you. I have one question to Professor Gamini also.
Yeah.
Gamini mentioned that they are applying 50% of imported fertilizer and 50% of BFBF, right?
Yeah, BFBF.
Yeah. And then got a 30% higher yield in the case of paddy. Okay, right. Then also you mentioned now you are trying 50% of organic fertilizer, something plus 50% BFBF, right? Yeah. So those studies is still going on, those trials?
Yeah. We have completed the initial research studies, and we are yet to report those things. And they have shown very clearly that we can go to that yield level even with organic fertilizer 50%. Because originally those granular compost, they are the good organic fertilizer types. They contain about 3 to 5 tons, 3 to 5% of nitrogen, like, which are very good as compared to the other compost types. And if you don't use biofilm biofertilizer, and if you are using only compost, we have to use about 400 kilogram of that compost per acre, or about 1 ton per hectare.
Yeah.
But when we use biofilm biofertilizer per acre, you can reduce the amount from 400 to 200. That has also been shown and proven.
Right. Would it be interesting also to check all three together? The BF
Biofilm, organic,
yeah.
All three. Yeah, we have really done some research studies at research station level. Yeah, that's also possible. Yeah.
For example, 30% from each or something.
Yeah.
Right. Thank you.
Thank you.
Okay, Professor Gamini and Professor Pillai, there's a very good comment by Mervin. He's in the chat. And he's also raised the hand that you may qualify for Earthshot Prize under the category Protect and Restore Nature. Mervin has raised his hand. Mervin, you want to explain that a little bit more?
Okay, a little bit. During COP26 summit, which took place back in 2021 October in Glasgow, to coincide with that, headed by Prince William and world-leading scientists, an award scheme was set up called Earthshot Project. The title Earthshot was actually a copy, a replicate of John F. Kennedy's original 1960s Moonshot Challenge, when he challenged the world, the scientists, to say, do whatever is necessary to put a man on the moon within 10 years. And he set up an award scheme, and that focused lots of minds, got scientists, engineers working together. It didn't take 10 years, it took shorter. Before 1969, obviously, the man landed on the moon for the first time. So this time, the so-called the Royal Foundation, headed by Prince William, have got inspiration from that and set up a challenge called Earthshot Challenge. And obviously, 2021 October, when UK hosted COP26, and obviously COP27 took place in Egypt the year after. So from that COP26, the Earthshot Challenge was set up under 5 categories. I have shared the link on the chat, so please click on that, see the 5 categories. And listening to, I'm a layman, so I have no know-how whatsoever about the science you described, but it's very much about restoring our depleted nature, degraded nature. And also I can't help feeling if the decision makers listened to the scientists and followed this method, Sri Lankan agriculture would have been green without getting into the calamity situation that we went into. That is an aside. But this invention, in my opinion, qualifies very much for an entry. You could very easily enter that and you stand a very good chance of winning it. The Earthshot Prize has got 5 categories, and it's over 10 years. Every year, a prize of £1 million times 5 for the 5 categories is awarded to the winner from 2021 to 2031. So this will be a wonderful opportunity for something that is really helping the nature, helping the mankind, and the Sri Lankan invention to get noticed, to get recognized, get the publicity, as well as win a prize. So I like to recommend that you sort of follow it through.
Thank you, Mervin. Fantastic opportunity there. What do you say, Professor Pillai and Gamini?
Thank you.
Okay, so thanks for that. And then I just want to deviate away a little bit to the problems in Sri Lanka. So one of the main weaknesses we have is that people innovate a lot of things, and you hear things in the papers and everything else, but nothing gets surfaced into commercial level. The main problem, which I have also seen, is that the patenting and commercial link establishment is very poor. There is very little support in Sri Lanka. And I visited once Malaysian University about 10, 15 years ago. And then when I asked about their innovation, they are very geared into preserve their innovations and also get commercial links. How it happens is, they say it's a university person who innovates something. Then the university takes over the whole process of patenting, and also finding a commercial partner. So if the product is profitable and they get a profit, then after all the expenses, the university will give 70% of the profit to the innovator, and only give 30%. So when we have this kind of thing, people get really interested in doing research. So how did you get in? Obviously, you must have had problems in patenting and getting this kind of thing commercialized. Any kind of suggestions for future for anybody there from Professor Gamini and Kule?
So we have to give the time to the lawyer.
Professor Kulasurya, can you make a comment, please?
I think what has happened now, things have changed a little from the time that Tula was here. Now most institutes have established units and cells to help the scientific findings to get out of the institute. At least I know at University of Peradeniya there is a separate cell administered by the Vice Chancellor and the administration to promote commercializations and things. What needs in Sri Lanka mostly is that the Sri Lankan entrepreneurs don't believe in their own people's findings. They consider whatever innovative finding that the scientists find, if they are Sri Lankans, they consider it as low in quality compared to foreign findings. This is very unfortunate, whereas some of our findings already have gone outside. For instance, the recent tragic assassination or death of a scientist while he was in Indonesia. I mean, he had been exporting liquid fertilizer for so many years to foreign countries, but nobody knew about it in Sri Lanka. Even with our findings, we have been writing to papers, we have been publishing, of course, scientific journals, loads of things which we don't expect the administrators and politicians to read. But whenever we come out and say these things, everybody just says, oh, we didn't know about it. We never knew about it. So I don't know how to, unless now, of course, it's social media, you can try that. But anyway, there is a gap. I think there's a responsibility for the institutes, research institutes, as well as universities to have a separate publicity unit to communicate these things, not only to Sri Lanka, but as quite rightly pointed out by Mervyn, we should also be informed of these opportunities. In fact, Gamini would have easily applied for this long time back. And maybe we can try, we may. Of course, we have sent some of this information, and I know it was included in the presentation at a FAO conference, Food and Agricultural Organization, which I submitted on invitation. That was a few years back, but it went there. That's about all. So this is the situation. I think, of course, right now our country has more urgent priorities to feed the people and keep the people alive. But besides that, there should be a systematic effort by the relevant institutes, universities, and the research institutes, and the mandated departments to publicize these findings and make use of them for the benefit of the people. That is what we need. But very few, unfortunately, very few of our own colleagues, they may not agree with me. All they do is they have a new finding, they publish it in a cited journal that increase their Google citations and so that, and that's the end of it. They very few try to get it out themselves. Whereas Gamini and I know that Lakshman at the IFS right now, we have a different attitude. We want to transfer the benefit to the public. That also should happen with our scientists. Thank you.
Great. Thank you for all the comments and all the presentation here, and we are proud of you. And but as you know, science is always a balance of probabilities, and then obviously some may not agree and so on, but that should not be a negative factor. That should be taken as a positive factor. So you provide more data to support your findings and then take it forward. And I was doing some research, and always my supervisors told me, you know, you find the answer out of research, but at the same time you raise a lot more questions than what you try to answer for. In any research, it's like that. So thank you so much. Any other questions at all? Any other questions? Any other questions? No? Great. Okay, thank you both, Professor Gavini and Professor Kule. Fantastic and wonderful. Yeah, have a good evening.
Thank you for inviting us for the.
Thank you.
Okay. Thanks.
Okay,
Thank
goodbye
you, Shula. This is a new opening.
Yeah.
Thank you. Yeah. Thank you. Bye.
Thank you, Chula.
Bye.